Hello and welcome. Today we are diving into the absolutely fascinating journey of AI in the world of software development. We're going to pull from a bunch of new research looking at papers like MapCoder-Lite and Asteria to see how AI is becoming practical, and then we'll see what it actually takes for an AI to really truly join a dev team.
Exactly. I mean, we've all seen those slick demos, right? An AI solves some complex coding puzzle in like 5 seconds. It's impressive. But the real question, the one we're digging into today, is can it handle the messy, complicated, and often frustrating reality of building real software in a professional environment? So to figure that out, we're going to follow the journey of this AI as if it's a brilliant, kind of quirky junior developer who just joined the team. First, we'll see how it gets smarter, faster, and way cheaper to work with. Then, we're going to throw some real-world problems at it, stuff beyond simple puzzles. After that, we have to tackle the huge issue of trust. And finally, we'll see how it all comes together in the real world and what it means for the future. All right, let's get into it. So our new AI coder shows up for its first day on the job, and we hit a massive snag right away. It's incredibly smart, no doubt about it, but it's also painfully slow and just way too expensive to run.
And when Clara says painfully slow, she's not kidding. Some of the early research on these powerful multi-agent systems found it took 27.5 hours to run a single benchmark test on a really powerful, expensive GPU. In a world of agile development, that's just a non-starter. You can't wait over a day for one result.
So the researchers got clever. Instead of trying to make one single massive model do everything, they took a different approach. They started with a much smaller, nimbler model. Then they basically froze its core knowledge, the fundamentals of programming it already knows, and on top of that they added these tiny little specialized adapters for each specific job, like one for planning, one for writing code, one for debugging. This way, they only had to train those little adapters, which is just so much more efficient.
And the results of that little trick, a 4 times reduction in both the memory it needs and the time it takes to actually generate the code. All of a sudden, our AI prodigy is fast enough to actually keep up with the human team.
Okay, but there's another speed bump, right? So much of modern coding is just waiting around for data from other services, from APIs. There has to be a smarter way than just asking the same thing over and over again, Theo.
Oh, absolutely. And that's where something called semantic caching comes in. The old way, exact match caching, is kind of dumb. It only works if you ask the exact same question twice. But semantic caching is way smarter because it understands the meaning. So if you first ask, who was the artist behind the Mona Lisa, and later you ask, creator of the Mona Lisa, it gets that you're asking the same thing and it just pulls the answer from its memory instantly.
And the impact this has is just huge. For tasks that do a lot of searching, this intelligent caching boosted the overall speed by 3.6 times. It managed to find a match in its cache 85% of the time, which basically eliminated all that waiting around for slow external APIs. So our AI coder is now thinking faster and talking to the outside world faster.
Okay, I'm with you. Our AI is now lean, mean, and cost-effective. But now we have a new question. Are we giving it the right kind of work to do? I mean, solving these little self-contained coding challenges is one thing, but real-world software is, well, it's a lot messier.
That is the million-dollar question. The early benchmarks were a great start, but they don't really reflect reality. Real code has to plug into other systems. It has to deal with documentation that might be confusing or just plain wrong, and it has to handle requirements that are changing all the time. We absolutely have to test for that. So, researchers started building new benchmarks specifically for this. Take a look at this table. It shows how different models did on a really common but tricky task, calling an external web API. And you can see, even a massive open-source model like CodeLlama only gets it completely right 30% of the time. The top commercial models do better, for sure, but it just goes to show that being a genius at algorithms doesn't mean you're ready for real-world integration.
And let's be honest, real development is almost never a one-and-done thing. It's a conversation. A project manager gives you some requirements, you build the thing, and then they come back and say, you know what, actually, can we just change this one little thing? How in the world do we test an AI's ability to handle that kind of creative back and forth?
Well, that's where the benchmarks themselves are evolving. Take a project called V-GameGym. Instead of just checking if the code runs without errors, it asks the AI to generate an entire visual game. And then it evaluates stuff that is way more subjective, but also way more important for a real product. Things like, is this game actually playable? Is it fun? Does it look good? Is it engaging? These are the qualities that make the difference between a simple script and a finished product someone would actually want to use. Okay, this brings us to what feels like the next huge critical step. Our AI coder is efficient, it's working on realistic tasks, but as the code it writes gets more complex and more integrated, a massive question starts to loom. Can we actually trust it to be secure? Yeah, this is a really big deal in modern software. Most applications today aren't built from scratch. They're assembled using dozens of third-party libraries. In a software supply chain attack, a hacker finds a way to poison one of those trusted building blocks, and then that poison automatically spreads to every single application that depends on it. And here is where it gets really scary. Security researchers discovered that these AI models can sometimes hallucinate. Basically, they just invent external components. So an AI might suggest using a code package that sounds real but doesn't actually exist. An attacker can spot that, go register that fake package name, and fill it with malware. The very next developer who takes the AI's advice gets their entire system compromised.
Wow. So how do you even defend against an AI that's just making dangerous stuff up?
Well, researchers came up with this really elegant prompting technique called chain of confirmation. It's a three-step process. First, you just let the AI generate its code like normal. Then you pull out all the external packages it mentioned, and you go back to the AI and ask it, hey, can you please confirm that each of these packages actually exist in the official library? And finally, you tell it to regenerate the code, but this time using only the packages it verified. It's basically like telling our junior developer, that's a great start, now go double-check all your sources before you commit.
Okay, so this is it. This is the moment of truth. Our AI coder is efficient, it's been tested on realistic problems, it even has a security check in place. But does any of this actually matter? In a real company with deadlines and a bottom line, does it make a tangible difference to productivity?
Well, one company decided to find out. They ran a year-long study with 300 of their own engineers using an in-house AI tool. And the first huge result they found? The time it took to get code reviewed and approved, the whole PR cycle, dropped by almost 32%. That is a massive efficiency gain in any engineering organization.
But this next chart shows the most telling result of the whole study. They compared developers who really leaned in and used the AI tool a lot versus those who didn't. The heavy adopters saw their total code output skyrocket by 61%. And the low adopters? Their output actually dipped a bit. The message is crystal clear. The benefits aren't magic. They're directly tied to how much you engage with the tool. And what about the developers themselves? How did they feel about it? Well, the survey results were just overwhelming. 93% of them said the AI assistant was so valuable that they plan to make it a permanent part of how they work. So it wasn't just making them faster in a way that management liked, it was actually making their jobs better.
So, after this whole incredible journey, it feels like our prodigal junior developer has finally earned its stripes. It went from being this raw, impractical talent to a trusted, high-impact member of the team.
It really has been quite the transformation. The AI started by becoming practical, 4 times more efficient. It moved on to handling realistic problems, not just puzzles. It became trustworthy by learning to check its own work for security flaws. And finally, it proved it was impactful, delivering real, measurable productivity gains in a real-world setting. It checked all the boxes.
And that really brings us to our final thought for today. The debate is pretty much over on if AI is going to be part of software development. It's here. The real question for all of us now is how we adapt and how we learn to collaborate with these new AI partners. So we'll just leave you with this to think about. What's the very first task you would give your new AI assistant tomorrow? Thanks so much for joining us.
See you next time.